I hope you are all enjoying your sessions today. My name is Asha Iqbal. I am the founder of Generation Reform, MQ Ambassador, and also a mental health campaigner. I'm going to hand it over to Peter Jones so he can introduce himself. He's my co-chair today.
Thanks very much, Asha. Good afternoon, everyone. Yeah, my name is Peter Jones, psychiatrist in Cambridge and an MQ scientific trustee. It's our real pleasure to introduce our speaker, Michelle Craske, to deliver today's keynote. Michelle is Professor of Psychology, Psychiatry and Biobehavioral Sciences, Miller Endowed Chair, Director of the Anxiety and Depression Research Centre, and Associate Director of the Staglin Family Music Center for Behavioral and Brain Health at the University of California in Los Angeles. There's really no one better to deliver a keynote today where we've been thinking about active ingredients. Michelle, we're really looking forward to your lecture.
Thank you very much. I'm very pleased to be here discussing the importance of moving our field forward by focusing on the active ingredients of psychological treatments. It's true that we have come a long way and that we have many evidence-based treatments for a wide array of mental health problems, but that we still have a long way to go because the majority of results show that anywhere from 50 to 55% of patients receive clinically significant response rate, and then of course we have the issue of relapse. Part of the problem is that our interventions typically involve multiple interacting elements with variations across studies in which elements are emphasized or how they're implemented. And as a result, it's difficult to evaluate the mechanisms of treatment and difficult to evaluate moderators of which treatment works best for whom, with the end result being an upper limit on effectiveness. Furthermore, our complex interventions impede replicability and synthesis of data, thus limiting our capacity to generate large data sets. They also limit identification of the active ingredients, those elements responsible for therapeutic effect, and conversely, the non-active ingredients, which should be removed in order to improve efficiency and effectiveness. By parceling out the active ingredients, we are able to identify the mechanisms that explain outcomes. We're able to identify the moderators of who responds best to each active ingredient, and even the moderators of the mechanisms, so that we can develop novel and more effective treatments. Now, there have been a number of attempts to identify active ingredients, one of them led by Bruce Chaw-Peter, my colleague at UCLA, who's been leading a major initiative to distill the distinct therapeutic elements from RCTs for youth samples. Now, this is a purely empirical endeavor and as such is limited to the result of extant trials. Ed Watkins has been taking an active ingredient approach in his online therapy study for depression called Improve 2. And here you can see the 7 active ingredients and their associated theoretical constructs. Work from my own group has also used an active ingredient approach at a more micro level by focusing on the sub-active ingredients, we'll call them, within the larger ingredient of exposure therapy, all of which is guided by a theoretical model that's called the inhibitory retrieval model of exposure, which in turn is derived heavily from principles of fear extinction and regulatory processes. Now, our exposure model has evolved from a large body of basic and applied research, some from my own lab, some from others, showing deficits in extinction and inhibitory processes as a strong correlate of anxiety disorders, a predictor of anxiety, and deficits that are occurring in the very process that is central to exposure therapy, deficits in extinction. And this is accompanied by disruptions in the neural threat circuitry, as you can see here, typically involving areas of the amygdala, insular cortex, anterior cingulate cortex, as well as the VMPFC and hippocampus. In our most recent work, we have shown that in a large group of 18-year-olds, those who show higher symptoms of anhedonia, controlling for all other symptoms of depression and anxiety, also show higher patterns of activation in some of these threat neural circuitry areas, including the amygdala, anterior, insular, left and right, and insular, and the dorsal anterior singular cortex, in response to the CS plus versus the CS minus during extinction. So what that means, in other words, is that they exhibit a failure of extinction, holding on to the threat reactivity to the CS plus, even though it no longer signals danger. And furthermore, in that same group, followed for over 3 years, we have found that those whose symptoms of general distress, which are shared between anxiety and depression, when those symptoms increase over a period of 3.5 years, they're accompanied by a pattern of worsening of extinction recall. In other words, they are failing to retrieve the extinction memory. This is a complicated slide in terms of the direction of effects, but it's worse general distress matched with worsening extinction recall, an effect which is largely driven by the subgenual ACC, which is closely related to the VMP-of-C. So again, deficits in extinction, both at baseline as a correlate of the increasing distress over time. So continuing on these themes of deficits in extinction at the neural level, here is our list of active ingredients and the associated theoretical constructs for exposure therapy, all of which are designed to offset the deficits in extinction. Now, I'll return to this later. There are a number of ways in which we can study active ingredients, as shown in this list. And the first few at the top here are referring more to mechanisms approach, and the bottom two are referring more to moderator analysis. I'm just hoping I can find my pointer again. So I moved. There it is. Sorry about that. I will not use my mouse. This is where so looking at the ways in which we can experimentally manipulate the purported mechanisms, that was the first on that list that I showed you before, in order to test theory and test efficacy to inform treatment development. And of course, this is where the majority of my research is focused in the context of exposure therapy. And I'm going to give some recent examples focusing on the bottom right context attenuation principle to start off with. In contrast to fear acquisition, which generalizes readily, extinction learning is context specific, such that the prediction error learning is gated by the context in which extinction takes place. And the consequence clinically is that exposure therapy effects often do not generalize outside of the therapy context. And we call this a return of fear. We've shown this in a number of times in human studies. Rodent research has elucidated the role of the hippocampus in the encoding of extinction contextual memories. And in fact, lesions of and pharmacological interference with hippocampal functioning using a drug called scopolamine has shown to effectively release context specificity of extinction in rodent samples. So we set out to release context specificity of exposure therapy by temporarily impairing hippocampal functioning as exposure was taking place by using the same pharmacological agent, scopolamine, in patients with social anxiety disorder who also had fears of public speaking. We double-blind randomized participants to different doses of scopolamine or placebo across 7 exposure sessions, and we used virtual reality to control the context. Of course, everything was counterbalanced, but they provided 7 one-minute speeches across each of the 7 occasions of exposure in one virtual reality context. And after that was over, we then tested them in the same virtual reality context or a different virtual reality context, drug-free. And since time itself is another context, we also tested them 1 month later in the same virtual reality context in which exposure was given, again, drug-free, expecting that if scopolamine was effectively interfering with hippocampal functioning, and if that would serve to release context specificity, we should see less fear arousal in the new virtual reality context, drug-free, and in the context 1 month later, compared to placebo. In order to test whether the scopolamine was exerting its effects upon the hippocampus, we tested a hippocampally dependent memory task, and indeed found that those who received scopolamine showed more errors on this task relative to the placebo group. As expected, we found that the scopolamine groups tended to show less fear arousal when they were tested in the novel virtual reality context than the placebo groups, whereas there was no difference across the groups when they were tested in the same context immediately after exposure. And 1 month later, the scopolamine group showed less fear arousal than the placebo group, drug-free, when tested in the same context. So the results partially confirmed the role of hippocampal processing in exposure generalization and suggest the added clinical value of scopolamine for treatment outcome, although the results were limited to physiological arousal and not self-report. And in other analyses not shown here, we found a moderator effect, whereby individuals who had poorer hippocampal functioning at baseline performed much better with scopolamine in comparison to placebo. Now let's take another example, which has to do with the consolidation of the memory for extinction, given our earlier evidence showing that deficits in extinction recall are characteristic of persons with anxiety. The implication being that while patients may achieve adequate learning during exposure therapy, as shown by our methods here, they may fail to recall that new learning once the session is over. So to address that issue, we manipulated a therapeutic strategy that specifically targeted memory for prediction error learning. We randomized patients to 2 conditions. In one condition, at 4 hours, 24 hours, and 48 hours after each exposure trial, they were prompted to recall the prediction error memory. And we compared that to a control condition in which they were prompted to remember something unrelated to their exposure. And we found significant improvement or augmentation of exposure in the blue group who were instructed to recall their prediction error memory. And remember that both groups received a heavy dose of exposure therapy, so to show a difference is impressive. In an ongoing trial, we are comparing the full inhibitory retrieval model of exposure therapy to an habituation model of exposure therapy. So again, manipulating active ingredients and purported mechanisms. And you can see here the list of the constructs associated with each treatment approach and the measure of the construct. We're still analyzing these data, but as a small glimpse, we've looked within the inhibitory retrieval model of exposure to see what predicted the long-term outcome in those with social anxiety disorder. And we found that change in the Liebowitz social anxiety scale, both anxiety and avoidance, was predicted by the change in expectancy violation throughout each exposure trial significantly, whereas it was not predicted by fear habituation. And we've yet to see whether the reverse occurred within the fear habituation group, and of course test all of our other measures. And finally, as an example of experimental manipulation of purported mechanisms of active ingredients, we've conducted a number of studies on the concept of affect labeling, which is an inhibitory process for down-regulating amygdala reactivity to emotionally relevant stimuli. And our most recent work is with vets with PTSD who use affect labeling as their shown combat images and nothing else but this as a treatment. And we found that this not only significantly improved symptom outcomes, but in a way that significantly and substantially correlated with reductions in amygdala activation as they passively viewed another set of combat images. Now I want to move to the next topic, which is sequencing of active ingredients. And here again, I'm going to be starting at the mechanistic level and talking about our work on positive affect treatment. So it began with a number of studies in which we've demonstrated that low positive affect or anhedonia is a risk factor for not only the development of depression, but also anxiety disorders. And this is coming from our longitudinal prospective work. And in the same group, we found that low positive affect is a buffer against the negative effects of chronic stress on the development, the onset of depression and anxiety. and that after controlling for other variables, interpersonal support from others, which is a primary pathway to feeling positive and rewarded, reduced the risk for the onset of depression and anxiety disorders. And in another project of 18 to 19-year-olds, that more positive events reduced the odds ratio of mood disorders, and that more positive events buffered the impact of high levels of negative events on the odds ratio for anxiety disorders. And furthermore, that we have found that those with higher levels of pleasure in reward, higher levels of positive affect, higher levels of drive for reward in the three top and bottom left diagrams show greater positivity when exposed to IAPS, positive images, and conversely, those with higher levels of anhedonia show the opposite pattern. We've also shown patterns of neural hypoactivation in response to rewards. This is a group of anxious and depressed patients, and as you can see in the area of the orbital frontal cortex, we see hypoactivation on the left side of the lower axis, the higher the level of anhedonia. So with more anhedonic responding, we're seeing less activation in the orbital frontal cortex in response to wins versus losses of the monetary incentive delay task. And this pattern is something we've replicated in another sample of 18 to 19-year-olds, again, a large sample with the exact same representation of lower activation in the orbital frontal cortex as anhedonia increases. And the orbital frontal cortex has been connected to the neural circuitry associated with reward responding. So all of this combined with some other data that we've collected have led us to develop a new treatment called positive affect treatment that is actually made up of a sequence of active ingredients with sub-active ingredients in each of them. As you can see in the table on the left, it's behavioral strategies in the first portion, which are activation to engage in rewarding activities. That's not anything new, but we combine it with mental rehearsal to enhance the details for the memory and savoring of the memory. They're called memory specificity imaginal recounting. Additional cognitive strategies are training to identify positive elements within complex arrays of stimuli and to imagine positive outcomes and attribute positive outcomes to oneself when appropriate. And then the final subset is called cultivating positive emotions through intentions and actions of loving kindness, gratitude, generosity, and appreciative joy. Now, we randomized anxious and depressed patients to either this positive affect treatment or negative affect treatment, which is traditional cognitive behavioral therapy for depression and anxiety. And across the board on almost every outcome, we found that the positive affect treatment was more effective than the negative affect treatment. And you can see in the depiction here that this is for positive affect itself. It's increasing over the first behavioral activation set of strategies and over the last cultivating positivity strategies, bringing positive affect up to what is the normative level in the population. There wasn't much change in the middle cognitive strategies, or in our subsequent replication with another sample of anxious, depressed, and anhedonic patients where we've replicated every single effect that we found in the first study. Here we see that positive affect continues to increase across all three sets of active ingredients. And furthermore, we've begun to look at the targets or mechanisms of change and found that positive affect treatment leads to greater change in mechanisms of anticipating reward using both self-report and physiological heart rate response to tasks. And positive affect treatment leads to more savoring of reward in both self-report and attentional bias dot probe tasks, and which is all a good indication of mechanisms, but the sequencing of active ingredients in this way does not allow us to tie these mechanisms to each specific active ingredient. And to do so, we need to dismantle PAT, positive affect treatment, into its different ingredients. And there it's listed as dismantling. And we've started to do that by using virtual reality, focusing in specifically on that behavioral activation with the imaginal recounting, using virtual reality so that we can experimentally control the kinds of rewarding experiences people are exposed to. And so in our first pilot trial, you can see here we're just highlighting that gold section, those particular active ingredients, by having patients immerse in rewarding virtual reality experiences, followed up by imaginal recounting and memory specificity training for that virtual rewarding experience, followed up by memory specificity for the autobiographical memories they've had and consolidation. And yes, this is a small pilot trial, but it was remarkable to us that in this small group of 6 very depressed and anhedonic patients, we got improvements across the board on every single measure, and even a signal at the neural level showing improvements in activation in the medial orbital frontal cortex during that same monetary incentive delay task that I referred to earlier. And we're now conducting randomized controlled trials with that virtual reality. I'm going to move now to fractional factorial designs as another way of studying active ingredients. And this is really where Ed Watkins' approach is leading the way. He's using a very complex factorial approach so that he can tease apart each of these active ingredients by presenting them in multiple different sequences with each other and looking at theoretically relevant processes. And that study, as I understand, is still ongoing, which brings us to what we are currently doing at the UCLA Depression Grand Challenge, and we actually are working with Ed Watkins in this. The UCLA Depression Grand Challenge is a large initiative designed to reduce the burden of depression. It has many different components to it. One of them is developing a scalable system of care to work with large populations. You can see here, this is a representation of our scalable model of care called STAND. It has online adaptive testing to screen people into different levels of care, ranging from self-guided prevention to online therapy to clinical care, with continuous tracking of response so that we can adjust the treatment rapidly, moving them up and down those different treatment levels of care depending on response, up to a higher level of care if needed and down to a lower level of care for maintenance. Where I'm going to focus right now is that middle tier 2 for mild to moderate symptoms, the online therapy. And for that, what we have built is an entire suite of active ingredients, an entire suite of modules that are taken from evidence-based trials for all of the problem areas that are listed on the left: depression, sleep, panic, social, worry, trauma. We're now adding in eating disorders, substance use disorders, postnatal depression. And the goal is to create these active ingredients that can then be selected for the individual based on personalized approaches. This is a web-based intervention. It's accompanied by a mobile app that provides guidance for tracking mood and behavior and tips and practices for the skills they've learned in the web-based treatment. And I should note that Zach Cohen, who is one of our DGC team members, has been developing this entire approach. And so our goal is to personalize not just the choice of level of care, tier 1, 2, or 3, but also once they're in, let's say, tier 2, which is the online therapy, that we can eventually personalize the choice of which active ingredient or which sequence of active ingredients is most appropriate. Currently, what we're doing is they come into the system, they complete a set of scales to choose which set of active ingredients matches their symptom presentation based on existing evidence. So if somebody has depression and sleep problems, they'll get the set of active ingredients known from prior research to be most effective for depression and sleep. We have an embedded measurement-based system so that this is just one of those sets of active ingredients, and we can track symptom assessments, as I mentioned before, each week. We add on process measures so we can look at theoretically relevant processes for each module, just highlighting here the being present module, and we look at engagement and technique use so that we can collect all of these data in order to inform our personalized algorithms. And as you can see, the being present module as one example of an active ingredient pops up in multiple different places across this whole program. We could use randomization, where we randomize the order in which the active ingredient is given, or which set of ingredients each client is given, but that would require extraordinarily large sample sizes given the large number of active ingredients that we're using. So instead, we're using what is called a discontinuity analysis approach, which is like a pseudo-randomization approach. We identify individuals who are very similar, but who end up being exposed to different active ingredients. So here are two individuals, they have identical levels of worry, but the orange person has a depression score that's one below the threshold, and a sleep score that's one above the threshold, whereas the purple person has the opposite, and as a result, they're exposed to two different sets of active ingredients. From this, we can compare things like the sequencing or timing of when they receive, for example, in vivo exposure, which there is called dealing directly with distressing situations. Or we can compare different versions of cognitive restructuring, whether it be balanced thinking or focusing on positives, two different versions of cognitive restructuring. Now, of course, this discontinuity approach is not ideal, but it does avoid the ethical considerations such as withholding active ingredients known to be clinically effective, or providing active ingredients known to be not clinically indicated, that would necessarily come about if we did do full randomization. And then, of course, our goal is to build the entire set of personalized algorithms so we can choose which active ingredient to give which person, while at the same time measuring theoretically relevant mediators. With an active ingredient approach, we need to have an agreed upon measurement strategy, one that takes into account not only the outcomes, but also the purported mechanisms, as well as the active ingredients in terms of their delivery and their receipt. And this is a program of research we're currently developing. And we need to move beyond the consideration of reliance of solely using self-report, whether it be questionnaire or independent interview, so that we can draw upon the information that comes from behavior and cognition and physiology and central physiology through neurobiology. The trouble, of course, is that when we're going into large-scale populations, it's not possible to do many of these tasks. However, there is some hope in that we can rely upon smartphones and wearable sensors in order to passively or actively measure most of those cognitive, behavioral, psychophysiological, and self-report features. And in fact, that is what we are doing now with the Depression Grand Challenge, to develop a way in which these observable processes can then be translated to emotional states, and use that to not only measure mechanisms, but also add to our algorithms for deciding what level of care should be given across our 3 tiers, and also which active ingredient should be selected for whom. So I'll finish by saying that if we can come up with agreed upon active ingredients, common measures, that we can generate large enough data sets to have a major impact on the field in the way in which these are delivered, that we can then have the right active ingredient delivered to the right person at the right time and go a long way. Thank you very much.
Well, thank you, Michelle. That was an absolutely wonderful talk, showing your very complete program of work on active ingredients, going from theory-based mechanistic research through to specific experiments on particular hypotheses, all aiming towards delivering better care. Thank you. Thank you for sharing emerging data. It's always a privilege to see that. And for showing us what you're doing in the UCLA Grand Challenge. It really is the epitome of personalized as well as precision treatments. I think it's an exemplar for any domain of interventions. Asha, I wonder whether you know what your thoughts are.
Hi, Michelle. Thank you for that. We are talking so much about lived-in experience today. Before this event, I actually watched your TEDx talk earlier on YouTube, so it was absolutely amazing as well. Listening about your experiences growing up with your brother and your family. I'm just wondering, how much has that influenced your work, and how much has it impacted on your work and what you're doing?
Oh, well, it's had a massive impact. For those of you who are not aware, my brother had very, very severe emotional problems, which led to enormous struggles for my parents, because they had no knowledge of how to handle it. And at the time, there was just really nothing other than very severe conditions of hospitalization. He was hospitalized from the age of 13 to 35. And it just, a constant awareness of there must be more, that there must be more that we could do. And so that really inspired me to go in this direction of trying to develop treatments that are more effective and that lead us to better outcomes than what he suffered.
Yeah, that's great. Thank you. And I do recommend for anyone that's watching to watch the TEDx talk, because it spoke to me so much just listening to your personal experiences, and you can actually see how much has impacted your work as well and why you're doing what you're doing.
Thank you.
Michelle, we've got a question. It's back to a slide fairly early on in your talk, where you were talking about the general distress, so the sort of what's common to depression and anxiety, something I'm very interested in, and the relationship between increasing general distress over the median term and the evolution of cognitive deficits, particularly retrieving extinction memories. And you said the cause and effect wasn't clear. I wonder whether you could just riff on that a little bit more.
Certainly, it is a complex set of findings, but this was a sample of 18 to 19-year-olds who we followed for 3.5 years. And we measured an array of measures. I haven't sort of presented all of it, but at baseline and then 3.5 years later. And using fear conditioning and extinction paradigms at baseline and then 3.5 years later, we looked at the role of various regions of the brain involved in extinction recall. Now, extinction recall is really an interesting and understudied concept from the human side. There's been a lot of work in animals, but not enough work in humans. And that's where all the action is really. It's the idea of once you go through an experience, how well do you recall that information, or how easily do you revert to earlier memories that preceded that experience? And so in this case, what we're finding is that as people become more anxious and depressed, so that general distress, their ability to retain or recall, at least at a neural level, their ability to retain or recall the previous safe information that, hey, you don't need to be worried anymore. This thing that you used to be afraid of is no longer dangerous. The ability to recall that seems to worsen over time. They get worse at recalling that information as they become more distressed. And that, of course, has major implications for how experiences in daily life actually play out. That they may have a negative aversive experience followed up by new information which says, oh, don't worry, that's not going to happen to you again, all is safe. But instead of remembering that safety information, they may have a tendency to go back and recall, no, this is dangerous, I need to be afraid and I need to be aware. So that's the sort of clinical translation of that finding. Cause effect, who knows? They're correlated. They go hand in hand at this point.
Yeah. There's a lot of questions coming through now, actually. I'm just going to check with the back room as to whether we've got time for one more. I know we will be able to forward all these questions. People are typing. I'm going to read out one more. Do you think there's a link between virtual reality and mental imagery strategies in terms of seeing and the emotional experience?
Very interesting. You know, we use the mental imagery, and here we were so guided by Emily Holmes's work. in a lot of our positive affect treatment, it's mental imagery, it's imagining future positive events. Virtual reality overcomes, in some ways, a lot of the limits that happen with mental imagery, because you're immediately immersed in what can be extraordinary environments. I think there is a correlation there. The downside, of course, of virtual reality is that you're dependent on an instrument. You're not learning a skill. And so in the end, I think it's probably a good thing to combine the two.
Yeah.
To do that.
Another interesting one is, can you tell us more about the patients in the UCLA program, how they react to the stand design, and do they like personalized precision therapy?
So we began this whole program of stand at UCLA with the UCLA College, university sample. So everybody at the UCLA campus was offered involvement in our program. It's open to anybody. And over a period of 2 years, I think we screened about 8,000 students, and a number of them, not many, I mean, the drop-off is high, but a number of them came into treatment. At that time, we were using a generic one-size-fits-all digital therapy program. And while it was good, a lot of the students told us it doesn't really fit their needs. Some of them would have sleep problems. Some of them would have trauma experiences. And that was the inspiration for us to say, you know what, we need to develop a more personalized approach. So now we're implementing that personalized approach, like I showed you, and we're using it right now in what are called community colleges around California. These are 2-year programs where mental health resources are extremely limited. And so far, the response has been very, very positive. But maybe if I come back in a year, I can give you actual data on that.
Great. Well, thank you very much. We've got to close now. That was a really wonderful keynote. And we'll send on the questions, and I'm sure there'll be a way to get your answers back to the delegates. So
certainly. Happy to do so. I'm sorry if my slides were a little bit not in order. I don't know what was going on there at some point, but I was very pleased to give this presentation. Thank you so much.
Super. Thank you.